Now let us try to understand about output delay. Here it is min. If it is min output delay is used for hold analysis, and for hold time, arrival time should be greater than the required time. And these are the changes in the figure. So it is set output delay hyphen min. So from here to here, we'll be giving some min delay, followed by this combo C1 should be min. So let us take the same values, time period as 10, source latency 0.5, network latency is 0.7. And first we are calculating the data arrival time, that is at port O1 of block B1, at port O1 of block B1. So for arrival time, first let us calculate like how much time it is taking for the data to be available at this particular O1. So as it is min here, which is something called as hold analysis. So for hold analysis, we'll be taking the same edge. So that's why clock rising edge is at 0. So total time is something which is 0. So active edge of clock triggering the flop at 0. So rising edge is active. Next, for this 0, source latency will get added up. So 0 plus 0.5, 0.5. For this 0.5, network latency got added up, which is 0.5 plus 0.7 is giving 1.2. So for arrival time calculation, we should not consider the portion which is present outside. Only we are focused about the what things that are present within the block B1. So we need to tell the delay that the data is taking within this block B1. So delay through C1, we are taking this value which is minimum value as 0.5. So clock to Q delay followed by C1 min delay is indicated using this particular line, and this min value that I am taking here is 0.5. So totally this 1.2 plus 0.5 will give 1.7 nanosecond. In the previous lecture about output delay max, we have taken the value which will be greater than this. Please check that video. Whereas here taking the value which is less than that. So total available time is 1.7 nanosecond. So data available at O1 is 1.7 nanosecond. So within this particular block, delay is 1.7 nanoseconds. So by 1.7 nanoseconds, the data will be available at this particular output port O1. And for required time, we need to calculate how much time this O1 is taking to reach to the data pin of flip-flop F3. So if you want to calculate the same thing by means of formula, arrival time is clock source latency plus network latency followed by clock to Q delay plus C1. And we should not take C2 and C3. Why? Because C2 and C3 is something which is present outside the block. So these two portions, that is C2 and C3, should be ignored. So arrival time is 0.5 plus 0.7 plus 0.5, which is 1.7 nanosecond. Remember this point, C2 and C3 should not be included in the calculation. Why? Because it is something which is present outside the block. So only consider till clock source latency, network latency, clock to Q delay followed by C1. Next, coming to the required time calculation, as it is hold, same edge should be used. So that's why incremental delay is 0, so total delay will be 0. Next, clock latency is 0.5, which is source. So add the 0 with 0.5, we get 0.5 nanosecond. And the 0.5 should be added with network latency, which is 0.7. And here the delay is 1.2 nanosecond. As we are doing hold analysis, we have to take the hold time of this particular flip-flop F3. So hold time is something which is present between the clock pin and the data pin of this particular flip-flop F3, and we get this particular value from the dot length. So in this case, I am getting hold requirement, I mean the hold value as minus 6.0. Remember one point here, for setup analysis, time period minus setup will be used, whereas for hold directly we'll go only with the hold requirement. So till here I got delay as 1.2 nanosecond. So add this 1.2 with minus 6.0, and I'm getting a delay as minus 4.8. Next, clock uncertainty is present. As I already told you, in setup analysis, uncertainty should be subtracted, whereas in case of hold, it should be added. So minus 4.8 plus 0.2, the output will be minus 4.6. So data required at minus 4.6 nanosecond. So if you want to calculate it by means of formula, it is something which is hold time plus clock uncertainty plus source latency plus network latency. We know source latency is 0.5, network latency is 0.7, uncertainty is 0.2, and hold time is minus 6.0. So if you substitute all this, you will get answer as minus 4.6 nanosecond. So required time is minus 4.6, and arrival time from the previous slide we got it as 1.7 nanosecond. And for hold time, arrival time should be greater than the required time. So 1.7 is greater than 4.6. So condition is getting satisfied. So that's why slack is positive. That is arrival time minus required time. So slack is positive, so hold timing on this path is met. So be clear with this particular figure so that you won't get confused. So in this video, we have tried to understand individually about set output delay hyphen min. So please go through all the lectures one by one and try to maintain some notes so that you won't get confused. Like why we are taking maximum value, why we are taking minimum value, and why we are subtracting setup time from the total time period in case of setup analysis, and why we are considering only hold time of that particular flop for hold analysis. Everything you have to maintain a particular note so that you won't get confused. So that's it about this topic. Thank you.